My dear students, let us move on to the third cubic unit cell, which is body-centered cubic unit cell. I hope you have understood the first and the second one. The concept is more or less similar, except the fact that in a body-centered cubic unit cell, the atoms are placed at the 8 corners and only at the body center. Okay, in face center, you have seen the atoms are placed at the 8 corners plus at each face, center of each face, there are atoms placed at the 6 faces. But in case of body center, we find atoms at the 8 corners and one at the body center whose contribution is complete, okay, whose contribution is full. Like for example, you have a box, in the box you have put a ball. So the contribution of the ball is one complete ball. Okay, in the same way, you find a ball or an atom here lying at the center, okay, at the body center. So what I've done certain modifications to the diagram. Here it's same, you have joined the diagonal here, but here you have an atom, and along this atom, along the body diagonal, you have drawn a straight line. Okay, so you have drawn a body diagonal here. So what you write in a BCC arrangement, 3 atoms along the body diagonal. Okay, 3 atoms along the body diagonal touch each other. That is the approximation, and that is what happens in real scenario. Touch each other. So the nearest neighbor distance between the atoms. Okay, let us consider this as D. Okay, let us consider this atom as say E. Okay, so nearest neighbor distance of this particular atom A to any other atoms located in the unit cell will be AE. Okay, the nearest neighbor of A is atom E. So D equals to AE equal to, once again, it will be AD by 2. AD by 2. Okay, now we'll apply Pythagoras theorem here. Observe what I am doing. In right triangle ADC, we know that angle D is 90 degree. You know, in a cube, alpha, beta, and gamma, the edge angles are all 90 degree. So we can safely approximate in right triangle ADC. Let us apply Pythagoras theorem here. The longest side is AD. The longest side is AD. Okay, so AD square is equal to AC square plus CD square. Okay, once again बच्चों, AD square जो कि longest side है इस cube का, right, body diagonal square is equal to AC square plus CD square. Now AC जो है previous derivation में हम लोग derive किया था. AC का वैल्यू इस ट्रायंगल ABC से हम लोग डिराइव किया था, और AC का वैल्यू मुझे मिला था √2a. Okay, if you want you can do it once more here, otherwise to save time you can just write 6, okay, here, or you can do it rough and show in the exam. Now AC is nothing but √2a from the previous derivation. What is CD? CD is also a edge of the cube, edge length, so it is a square. So it is 2a square plus a square. Comes out 3a square. So AD square is equal to 3a square. This implies AD is equal to square root of 3a. 3a, root 3a units. That is your AD. Now let us find out the nearest distance. If AD is root 3a, don't need to mention, I'm just giving you an idea. If AD, the whole length of the body triangle is √3a, now what will be the distance AE? Distance AE, it is a symmetrical figure. Cubic unit cell is the most symmetrical of all the unit cells. So in a symmetrical system like scenario, AE will be half of this √3a, right? We know that AD का half क्या होता है? AE होता है. So therefore, D is equal to, what is that all of you? AE is equal to AD by 2. Okay, so it is √3a by 2. √3a by 2 units. Now once D is calculated, you can find out the radius of the unit cell. Therefore, the radius of the atom R is equal to D by 2. And बच्चों D क्या है? √3a by 2. It comes out √3, 2 2s are 4. A. So this gives me the relationship between the radius, the edge length, and the nearest neighbor distance. I hope you have understood. Please copy it up to here. We'll be doing numericals in due course of time. I hope it's well and clear for everyone.